All right, so this is going to be the last section of chapter 4, section 4.8. And so now we're going to get into the polarity of molecules. We're going to combine what we've learned about the molecule shape and the bond polarity to determine if the whole molecule is going to be polar or nonpolar. And so when we're looking at the polarity of the molecule, we're looking for two things. We're looking at the overall shape of the molecule and the polarity of the individual bonds. Sometimes the overall shape of the molecule is going to determine the polarity no matter what the polarity of the bonds are. And sometimes you need to look at both. With covalent compounds that have more than one bond, the shape of the molecule really determines the polarity. And so that's what I was just saying. And sometimes the polarity of the individual bonds doesn't really matter. We will sometimes have to look at both. So when we're looking at the shape, we're looking at a couple of things. If we do have to look at the individual bonds, if we look at those dipoles, those pulls, thinking about the tug of war type of situation, if the two dipoles do not cancel, the molecule is polar. That means if one side of the molecule is going to win the tug of war, the molecule is going to be polar. But if you have multiple dipoles, and so you have people pulling on the ropes, but they cancel out because they're the same strength on both sides, the molecule is nonpolar. This is going to make more sense with an example. So to determine the polarity of a molecule with two or more bonds, first we're going to just look at those polar bonds, maybe draw a dipole, look at our shape, and then we can tell if the dipoles cancel or reinforce. So here, let's look at this one. So I drew it in the right, this is in the correct shape. This is trigonal planar. We have one polar bond, and that polar bond is pointing toward the oxygen. So we just have one tug of war happening, and there's a tug pointing towards the oxygen. Nobody is tugging to the left side. So this whole molecule is going to be polar because there's just a pull in one direction. There's not a pull in the other direction. There's no pull to the right or to the left. There's only pull to the right. If you have a situation like this, where we're pulling in all three directions, those pulls would actually cancel out, because if you're being pulled by three equal forces in that 120 angle, nobody's going to win. And so think about this. If you pull here, you pull here, you pull here, nothing's happening. Nobody's moving because the up pull is canceled out by the two half kind of down pulls on the side. And then the left pull is kind of canceled out by the right pull, essentially. So we would call this a nonpolar molecule because all those different pulls cancel out. All those dipoles cancel. Now here is an example of a trigonal pyramidal. Trigonal pyramidals are always polar. So let me just write that. Trigonal pyramidal. Always polar. The trigonal pyramidals are always going to be polar, no matter what their bonds are. Because you have that lone pair on the center, it's always going to be a little bit off your electron sharing. There's always going to be like electrons somewhere where there aren't other electrons. And so here, if you actually look at the pool, you have all this pull up, and you don't really have any pull down, right? So your net dipole, your total pull, the direction that all of them would kind of be going if we were doing tug of war situation would be up towards the nitrogen. And then here, this is a tetrahedral. We have two polar bonds and two nonpolar bonds. Notice the nonpolar bonds do not get dipoles. They don't get the little arrows. They're not participating in the tug of war. We have a tug up, and this is not a tug right. This is well, it is kind of a tug right, but it's a tug back into the board, back into the screen, back into the paper. So we kind of have this net dipole kind of up and to back. And we'll talk about this in class a little bit, where I can give you more of a three-dimensional thing. One common misconception is that if I have something drawn out like this, it looks like it might be nonpolar, because it looks like maybe we would have these dipoles cancel out, right? But you've got to remember that it's not in this 90-degree flat shape. It's actually looks something probably like this, where this chlorine is actually coming out of the page at us. So really we have a pull up and out of the page. So it's not really canceling out the pull of electrons here. So we have a pull up and then we have a pull out of the page, and that's not really canceling out. So just be careful when you go to determine is it a polar molecule or not, that you're actually looking at the shape. So trigonal pyramidals are always polar. Let me just write this down here, I think, separately. So always polar shapes. There are two shapes that are always polar. This makes it really easy. No matter what your bonds look like, always polar shapes are going to be trigonal, pyramidal, not trigonal planar, trigonal pyramidal, and bent, either bent. It could be bent with the 120 bent, or it could be bent the 109.5 bent that we talked about. Either one of those bents that we mentioned are going to be always polar no matter what. Now notice I didn't say that all linears are nonpolar. I didn't say that all trigonal planars are nonpolar. That's not true. These three shapes are always polar, and the rest of them you kind of have to do this trick where you look and see if it cancels out or not. So this is definitely a topic that builds. You have to be able to draw your Lewis structure, then you have to be able to tell the shape, but then you have to be able to tell if the bond is polar or not, and which direction you would have a pull based on electronegativity differences. Then you can determine polarity of your molecule. So chapter 4 really builds upon itself so that you can't really do the molecular polarity at the end unless you kind of have the rest of it down. So please ask for help if you need it. If you need me to break something down for you into smaller chunks, please do so and get a lot of practice here. This would be really helpful for you just to get a lot of practice, especially in drawing those Lewis structures. All right, let me know if you need anything.